Yeah, sure. So just let me know when to start and I will start.
Okay, I think we can start. There are folks already in the room as well.
Cool. Uh, so yeah, I had to mute myself on YouTube because I could hear my own echo. Right. So today's session is about setting up and monitoring home networks by Karan. Now, Karan works for Zerodha, and the idea for this came out to be from uh, this forum which Karan and we both hang out in. So I was initially curious about monitoring networks and in general just my network and not just like internet being up or down, but the quality of service as well. Because although I've been working from home for quite a long time, but after this entire lockdown thing started, the quality of internet would vary on day-to-day basis. So where were we on a particular day was like a question which I was looking at trying to answer. So I looked at various different things like debugging from just my home network using SNMP and stuff like that to monitoring what the quality of internet was and my upstream ISP and how was their connection to the internet as well. So I was just like tinkering with various different softwares, and I came up with this one stable sort of setup of using Telegraph for polling all the information and storing it in InfluxDB and then displaying it using Grafana. So I created this one very rudimentary dashboard, which was supposed to be only for my consumption and just to show me what where on that particular day my internet connection looked like. I had shared this on this forum, and Karan was a little bit interested, so he kind of picked it up and refined it, made it a little better, and then shared it with the internet. And I think his tweet kind of blew up. So at that point of time, folks from Hasgeek contacted him and me, and here we are giving this talk. So Karan, you wanna take it away?
Sure. Thanks for the intro, Gaurav. Before that, just let me quickly share the screen for the slides. Is the screen visible?
Yes.
All right. So, hi everyone. Thanks for tuning in. I am a DevOps engineer at Zerodha, and I'm primarily interested in monitoring and observability systems like using using Prometheus and Grafana. I also have a blog where I share interesting things about monitoring and just networks in general at mrkaran.dev. And I also happen to have my own self-hosted stack of applications that I use. So uh, this monitoring thing is also inspired from the same set of principles where I host a lot of applications, so I need to monitor them. So I thought, why not monitor my network as well? So we are in the lockdown since like 7-8 months at the moment, and uh, ISPs of all the things have taken a huge hit because everyone's been working from home. And as you know, that retail network lines, they are not really meant for such high load at a very sudden spike. The moment the lockdown has been started, there have been some of the other ISP problems which keep on happening, and people in various groups keep on reporting. So what I wanted to see was what kind of problems is my ISP giving me, and a lot of times it happens that sometimes your friend pings you that, hey, check xyz.com is up or not, and your internet, it might be fine, but his internet, there might be issues, and it happens even with the same internet provider. So I used to have a lot of these conversations in my company group. So I thought, why not just kind of get an overview of how the network is basically performing. So that was the whole idea behind monitoring my ISP. So before diving in the final solution, I had a couple of alternatives which I'd like to discuss here. One of them was SmokePing. So SmokePing is a very old monitoring solution for network, basically, where it's a PHP application, and it gives you a lot of interesting information about your network using ICMP probes. So but the problem with this is that it comes with its own graphs, its own monitoring and alerting system. And I was already running Grafana in my own DigitalOcean VPS. So I didn't want to add another monitoring service just for this one service. So that's the only reason I decided against SmokePing. The other was a speed test CLI exporter. I actually ran this for a week or something, but then I realized every speed test you do, it costs you around 50 70 MB of your bandwidth. And running this frequently every 5 minutes or something, it's not really recommended if you are on a internet plan which has FUPs, which is basically almost every plan, a retail plan. So that was one reason I didn't go ahead with speed test. Other than that, another reason is that a lot of ISPs peer into the upstreams which speed test site uses. So you might get a flawed information that your internet is working fine and fast, but it can happen that a lot of regions are very slow for your internet, and that happens and that doesn't simulate the real life browsing experience. So it's like comparing just benchmarks versus real life experience. So that's why I thought, okay, speed test is not a great idea. Then before I interacted with Gaurav, as he said on the forum. I was almost tempted to go ahead with my own simple uh, solution, which was just to ping a couple of sites in a shell script and output them to a SQLite DB. And I have written a program, Golang program, which converts the DB data to Prometheus output format, Prometheus wire format. So I was almost tempted to go ahead with this, but then when I interacted with Gaurav, and I found his solution is much more superior and does basically the same thing. So I thought I should not rather reinvent the wheel and check out Telegraph. So Telegraph is basically it's also a Go program, and it basically has this concept of plugins. So plugins are just agents where you can give input, output, and filter plugins to do a lot of custom monitoring stuff for your infrastructure. So I was particularly interested in the Ping plugin, which basically uses Glinted Ping, which is a Golang dependency. It also comes with a native mode where it just runs a ping executable available on your operating system. So you can specify whatever mode you want to run it with. I chose the Golang mode because it's more consistent across OSs. And I was rather very confused about this fact. I had a wrong assumption about Telegraph that it only works with InfluxDB, but that's not true. I was looking around the documentation, and it actually supports an output plugin to Prometheus. So that was perfect for me. I really just wanted the Prometheus format for my existing monitoring solution. And it's not just Ping plugin. You can even run DNS plugin, which I'm running because I have my own DNS server on Pi-hole, which I wanted to monitor as well. And you can even run HTTP plugins, which can monitor the layer 7 upstreams basically. Telegraph configuration is very simple. I'll share a sample configuration in the after this session is over. But the basic idea is, like I said, you just have plugins. So input plugin, you define, it's in the toml format, and it's very honestly, it's very refreshing to see toml over YAML in any of the ops tool these days. So yeah, you just give a bunch of upstreams, and you these are all the standard ping arguments that you give, and you just specify the output plugin right now, which I already told it's Prometheus for me, and you just get these metrics in the Prometheus format. So these are the type of metrics it exposes for the ICMP monitoring, and you can basically get a lot of data with just 3 or 4 metrics using by writing queries using the PromQL, which is the Prometheus query language, and visualize this in Grafana. So if you see, this is the basic dashboard where I have a list of upstreams which I have defined in my configuration, and I use Grafana to basically visualize all the metrics which are flowing in. So I'll just go through a couple of patterns that you can uh, uh, gauge through all the metrics which are exposed by Telegraph to sort of fit in your use case about how your monitoring, or how whatever the use case you are looking for, you are able to do it yourself basically. So one of them, it's a packet loss issue keeps on happening almost like fairly uh, frequently, because let's say let's say you are in Delhi right now, and upstream in Singapore is failing due to ISP routing issues. So these are very frequent, but packet loss beyond a certain percentage, that's when it kind of impacts a real browsing experience. So in my particular use case, what happens is, if I see a lot of packet loss, I tend to reboot the router, and that kind of fixes my problem. If you notice that on 1050 I just lost my internet, and before that I was getting some packet loss. So what I do is, I can basically I can plug these Prometheus alerts to alert manager, which allows me to define a webhook endpoint, HTTP webhook endpoint, and there I can write all my custom scripts. Like if uh, if I get a packet loss alert, I can just do a reboot, sudo reboot. So I'm running this on my Raspberry Pi, and I just have all of this is localized. So I just have all the shell script and all the very basic HTTP endpoints written over there. Secondly, this one pattern where basically I had a uh, downtime during the night because some ISP maintenance work was happening or something like that. And before that, also, you can see the ping time had spiked up. So basically, you can gauge how much percentage downtime your ISP is giving you. But sadly, in India, or I guess anywhere, you can't really enforce these SLAs, at least on the retail connections. If you're on corporate lines, then it's a different thing. But yeah, if you're on corporate lines, then this can be useful, because you can have your own uptime metric, and you can give them a report that if your SLA is breached. But interestingly, and this happened just yesterday, as I'm giving my talk on my mobile internet, and this talk is about monitoring your home internet. So what happened was, so I have Airtel in my hometown, and Airtel just started randomly digging in just front of my house in the name of just putting in fiber cables. So I'm not having internet since like last 30 years right now, and this is the uptime metric I've captured. And this is 24 hours uptime metric, which was taken in the afternoon. So I still don't have my internet, but at least I have my graphs to see that I don't have internet. Um, So this one is also interesting. So there's a metric called ping result code in Telegraph, which gives you one or zero value. Zero means it's successful. One means that the host is not found, and actually it returns two also. Two means some other error. So one means a host not found. That means it's a DNS problem. Like all the other things, it's always DNS. So you can see the both the time frame actually match with some issues in my DNS server. So this is the graph of the DNS query time, where the DNS query time just on an average it just spiked during 2:40 to 3 p.m. And that's the same time where my ping result code was also showing some DNS related issues. So that could possibly mean that either my pi hole or the way I connect through my DNS server, which is Tailscale, which is a WireGuard mesh network, either of these were having issues. And if I want to dig in, I can basically get some more information from this graph, and I can dig through the problem. And yeah, this is again packet loss metric, where I can see if packet loss is more than X percentage. 40% is really noticeable if you're browsing any site, because like in a TCP, a TCP packet has to go back and forth if such high packet loss is there. So you can see which particular upstream you get this packet loss, a very high packet loss for basically. So it usually happens for the sites in uh, US East one or similar areas where the ISP routing is not really efficient, or in the cases where the CDNs are hosted not in the country but in places where your network, your ISP operator doesn't have a proper peering to it. So you can see that as well. I can show my dashboard as well in just a minute, and we can just interactively browse it. And
This was definitely cool. I think there is a question in here in the chat for you, Karan. It says ICMP based monitoring for website does not give accurate results. So, yeah, your take on that.
yeah, that's very true. And I mentioned in my blog, some of the upstreams even block ICMP, like even github.com, netflix.com. If you try to monitor them, they'll just outright block your ICMP. And also, if your website is behind a CDN, you're actually just monitoring the CDN endpoint rather than your own endpoint, because a lot of these CDNs, they won't forward your ICMP packets to the upstream. What mattered for me wasn't monitoring the endpoint itself. So it's for that I'll just do a layer 7 HTTP based monitoring. For me, what mattered was just to get a general overall picture about my about the network health and the sites that I basically frequently visit, and I know they are spread across regions all over the world. So in that way, I just get a overall picture of how my ISP is performing. It's not really a particular endpoint monitoring. For that, you should use HTTP or other metrics if you can. And this just tells me, okay, some problem is there. Then if I need to dig in, I can basically do a trace route, and or basically do other kind of metric monitoring, because like Hasgeek had a webinar on ripe probes as well, atlas probes as well. So even that gives a lot of useful information, so that helps to debug those problems.
Uh, cool. So, there is this another question from Pravas. So, it says, So I may have heard it wrong, but did you mention using Prometheus and Influx both part of your stack? If so, was Influx being used only as a data store for Prometheus? I can give my take. So I'm not using Prometheus at all for my use case. I'm using InfluxDB, like only InfluxDB. There's no Prometheus in my entire setup. What about you, Karan?
Yeah, so I don't have InfluxDB at all in my stack. What I have is just Prometheus, Grafana, and the exporters which are running just as a stateless process in my Raspberry Pi. So how am I? Like I mentioned, Telegraph seemed very appealing to me because it could just outright export the matrix in Prometheus format. So it doesn't. I just use Prometheus as my timescale as a timescale DB, and if so I really don't need to use InfluxDB in my current stack. And how it's architected is the Raspberry Pi runs the exporter, which is connected to my home internet using a LAN cable, and I use something called a Tailscale, which is a mesh network based on WireGuard VPN. And I have a DigitalOcean of like small $5 instance running in Bangalore. So the Prometheus is connected. Prometheus is basically listening on Tailscale interface, and my exporter is Telegraph exporter is also listening on Tailscale interface. So that's how they just talk to each other. So yeah, I mean, I don't really have InfluxDB in my current stack.
Yeah, I guess it speaks a little about Telegraph, right? It's kind of
Yeah,
flexible. You can use it with either
yeah,
InfluxDB or with Prometheus. The reason
yeah.
I went with InfluxDB was because InfluxDB integrates really well with a couple of other monitoring I'm doing. Like I'm also monitoring using SNMP. So I'm using the SNMP plugin in Telegraph. And the entire stack for doing SNMP monitoring was kind of really easy. So I found that using Telegraph and InfluxDB, you could do both, like external as well as your internal monitoring. So
Right, right. Is my browser tab still visible?
yeah,
Okay. So like I was mentioning about the Grafana dashboard, you can see the DNS. This is also a Telegraph input plugin, and it's just a metric which tells you the response time for the DNS queries. There's a DNS errors also, which will tell you if any UDP errors are coming in a DNS server. Other than that, there's a very simple uptime metric for the endpoint as well, which just subtracts the packet loss from 100, which will just give you a general idea that how much packet loss percentage your endpoint is having. And this doesn't have to be, you just have to be careful that you just use it for a general curiosity or like monitoring purpose, not for the actual endpoint monitoring, because like someone mentioned in the chat also, ping is not a reliable way to monitor this. Yeah, all the other metrics, they are pretty basic. This is my main Bangalore VPS, and all the ping response time metrics are just plotted over here. Yeah. In case anyone has any specific question, I'm happy to answer.
cool. I kind of have a question. So are you also planning on monitoring your internal network or just like the external stuff?
Internal network, like using, like, you mean all the services that I'm hosting, are they up or not, like that, or
No,
the
as in your home network.
okay, so you mean the Tailscale mesh network or like Raspberry Pi and okay, okay.
Yeah.
So I haven't really digged into that right now, but I mean, yeah, that sounds interesting because what happens for me is Tailscale just takes care of all the part where you just connect your devices, and it's pretty cool in a way that I can just visit a container which is running in my laptop. I can just listen on Tailscale interface and just put the address in my mobile, and since mobile is also connected to Tailscale agent, they both can talk to each other. But I haven't really looked into how I can sort of put monitoring into it, because I think I'll need some kind of deeper, like layer 4 kind of metrics running through the network over there. But I do have a basic like node exporter running in both Raspberry Pi and DigitalOcean there as well.
Yeah, so I think since we are talking about home networks, right? Like I can probably share how I'm monitoring my home network. So I'm basically doing the same thing as you are, like running Telegraph on a Raspberry Pi instance. Uh, but I've also enabled ICMP uh, mm, metrics for my router. So that displays all like a lot of metrics which you see inside your router as well, and you can use that for like you can monitor your home network using your whatever your router sees, right? So
Right.
that was like a previous version where I was trying to figure out how to do this, and the initial router firmware that came with my router did not support ICMP. So I just flashed like one of these open source router firmwares,
Yeah.
and that basically helped me export all of that information. And after that, I kind of invested a little bit more money and switched over to Ubiquiti, like using Ubiquiti Gateway and Ubiquiti AP. And the interface for Ubiquiti is really nice. Like by default, it gives you a lot of information in there by default. But if you want to integrate that with your entire Grafana dashboard, you can do that also. Like they're already ready-made unified dashboards present. So you just have to go to the Grafana website and just download one of those dashboards. Maybe I can quickly like share
Sure.
my dashboard over here for my internal network as well. Share my screen, uh, application window, Chrome, share. Can you people see my screen? Let me know if you can see.
Yeah, we can.
Yeah, so I mean, none of this is created by me. I'm just leveraging the stuff which has been done already by other people. But uh, like investing in kind of prosumer uh, hardware, it gives you kind of feature-rich stuff which you can already leverage from other people's work, right? Like all I had to do was set up Influx TV on my Raspberry Pi instance, and yeah, and this dashboard is not created by me, so I can already monitor a lot of stuff on my internal network itself. So there's a lot of information which is being shared by default uh, without having to do anything. So this is basically just a plug and play operation now, uh, because I didn't have to like do any of this stuff. So yeah.
That sounds cool. And even Ubiquiti, they have a new retailer in India as well, right? Like
Yeah,
recently.
so yeah, that's true. So Ubiquiti had a new retailer in India, and they started selling all of their hardware uh, locally also. Uh, it's a little bit It's a little bit expensive, but the convenience factor and the nice UI you get in return, I think, for my use case, it was worth it. So I kind of switched over to Ubiquiti stuff, and yeah.
Right.
So, are there like any other questions?
Hi, Karan. Taz,
Hey, hi.
Hey,
nice, nice presentation, nice stuff going on with respect to monitoring. So I had a couple of inputs with regards to let's say you're running probes, or you are probably interested in leveraging the Atlas probes and plugging that data into your, let's say, dashboards, right? So there is a Prometheus exporter called as Atlas exporter, which you can probably explore. And it's a cool thing because it gives you the power of running a streaming or a live measurement into your dashboard. And the same guy who has written this in Go also has a ping exporter. So I highly recommend that you check that out as well. So this kind of opens up a lot of possibilities. So in my case, I am also using Prometheus and using InfluxDB, as well as using the Atlas exporter with a streaming measurement, which tells me latency from my network towards, or latency from specific networks in India towards, let's say, the root servers, right? And that's pretty cool, because that tells you how the root servers are behaving at any point of time. And it also tells you um, how much of traffic is staying within India and how much of traffic is kind of transiting outside of India. So for people who may not know about DNS root servers, so we have a lot of instances of root servers within India, IPv4 as well as IPv6, especially the F root server, say for example, and even the K root server with the RIPE NCC. But number of times I have been monitoring the fact that traffic will not hit the local instance. The traffic will go outside India, right? So this becomes an excellent way of having an historical understanding of what is happening there. So that could be something that people can explore.
Yeah, that's very interesting and nice input. I hadn't thought about that, like integrating that with Prometheus. But yeah, I think Hasgeek also had done a previous session on Atlas and Oni probes. So yeah, if people are interested, they can go check out that stuff.
The other thing, probably what I'll add to the mix is, I'm just assuming here that you have multiple internet connections like I do, is monitoring on that front as well. So if you have, let's say, two internet connections, how are you folks, monitoring both the internet connections? What kind of hardware are you using, if any, and what tweaks to the setup to do that?
So the unified gateway which I have, it has two WAN in ports. So theoretically, I could connect another one, but I've just decided to YOLO, and I'm on like only a primary single ISP. The other one is just my 4G network, which I'm using. But yeah, this is something which even I'm interested in. So if there are any thoughts, please let me know also, because that will help me figure out how to integrate both the two different ISPs into a single network.
So I have been thinking about getting a secondary backup connection, especially after yesterday, since my internet has been down for like 30 hours. So what I was thinking was self-hosting just a DHCP server and integrating alert manager alerts where I monitor either of the networks and kind of switch the endpoints inside my Raspberry Pi. So I want to use my Raspberry Pi as a router and connect to both the internet routers using that, and just depend on Raspberry Pi for my routing use case. So
Yeah. So in my case, I have multiple connections, and what I'm using is basically um, a dual WAN setup. It's something that I picked up some time back, and I use policy routing primarily. If you haven't explored this, so policy routing allows you to have policies where you could save. So I have multiple probes. So I have two internet connections, and I have two different probes, software probes behind those two connections. Now, what I do not want is, say, for example, if primary internet connection goes down, I don't want all traffic to move to the secondary, because I don't want, I want this first probe to go offline, right? Because that's what it is configured. So using something like, I mean, there are many ways to do it, but one simple way of doing it, or effective way, which I could, think of, is using policy routing, and that kind of solves that problem. So while the first connection primary goes down, the first probe will also go down, but at the same time, the rest of my devices will switch to the secondary, and vice versa. So that is something that you could explore. So the ubiquity devices, the USG or the edge router, you could do that there. You could use pfSense, whatever it is. You could take an x86 box, put an additional NIC in it, and configure that as a router. You could use OpenBSD or even FreeBSD and do it. I mean, choose whatever works for you the best.
Regarding this splitting traffic, so even I tend to do that, but using DNS. So I run a local core DNS server, and I basically whatever the DNS zones that I want to set of particular DNS zones that I want to whitelist, I just split my traffic based on that. So maybe you can also check that core DNS as well.
So I had a question, Swapnil. Uh, you were talking about using BSC and PSMs and stuff like that, right? Is there any like ready-made, easy to roll out solution for using two different ISPs? Not in a like active passive way, but in like kind of a load balanced way or something. Because the problem which I think I would run into is like having those sticky cookies, right? If some of my packets are going through one ISP and some of my other packets are going through the other ISP in a load balanced way, then it will kind of break my sessions, right?
Right. So one BSD option, which is probably has a UI, is pfSense. So pfSense is something that people can explore if they just want, instead of using policy routing, if they just want to switch between multiple connections, that could be one option. There are many others. I mean, if you just search for alternatives, you'll find many. On your specific question, the latter part of the question, where some part of the traffic is going this way, I mean, one through the first connection, and some part is going, I mean, it depends on what you're trying to do. So in my case, using policy routing, I have a lot of things in there where I have so I have a lot of devices. In fact, it kind of reminds me that I need to get a rack, a full-fledged, full-blown rack, because my home network is an enterprise network right now, where I'm kind of looking at PCAPs, taking all the traffic using a span port, and doing a lot of things there. But as an example, I have certain devices which I always want that traffic for those devices should go through, let's say, the primary internet connection. And there is the other part of the rest of the devices, like say in my home network, my family, whatever devices they are using, although I'm at home, I don't want them to pester me with respect to that the internet is down all the time. The network NOC is right besides in the next room, right? So I primarily don't want to fiddle with any sort of meddling with what happens to those devices. So there is a free flow with respect to those specific devices, where if primary fails, everything switches to the secondary, and if secondary fails, I mean, or whatever, it vice versa comes back to the primary. That's what I have in place. I hope that answers your question.
Um, what if I do not want to roll out my own hardware? Are there like any ready-made products which would integrate two different ISPs into a single home network? I guess it would be interesting for other people out here.
I don't think that would be seamless and possible without having a hardware in place, because the logic is being done in the hardware device. It could be an x86 box, or even there are the other things which I forgot to mention, which one people can explore, is there are a lot of these routers. Let's say TP-Link as a very common popular brand in India, right? So there are a lot of these TP-Link routers which you can put OpenWRT or open source firmwares like what you were talking about earlier, and you could configure the multi-WAN setup using the most economical TP-Link router. But the problem with that is having a compatible router which works with OpenWRT or any other open source firmware is always a question mark. So in my case, I had also explored that. So there are a couple of, so if you go to the OpenWRT, the wiki page, they have a, I'll put the link in the chat as well. So they have a page where they list the hardware compatibility. So if you search for TP-Link, it tells you which version is compatible, which model, and so on. So you need to be very picky about it. So in my case, it was me calling up the distributor and saying, okay, I need this specific version and I'll pay you the money, but before you ship it, please send me a picture of it so that I know that this is the exact version, right? So there is a bit of a work that people have to do if they want to go for the simplest option, but it needs some sort of detailed look into which those devices are. So that is another option which I've also seen people exploring using something like a Raspberry Pi using an USB to Ethernet. But there is an issue with that in the sense that if you have connections which are faster, and the Pi version 4 is much more powerful, but previous to that is not. I think there is in the previous version there is also the sharing of the bus on the hardware front as well. So it may not work from a performance. I have never tried that. I mean, just to let everyone know, or the Raspberry Pi route is something that I've never tried.
I think there is a hardware by TP-Link, which I think they market it as load balancer router, can take like 1 to 4 WAN connections and then give you one single LAN. I see there are some, like I foresee some issues with that hardware. One being it's 100 Mbps limited. So if you are having like uh, a connection more than 100 Mbps, even two connections with 100 Mbps, it will still output you like 100 Mbps stream, right? Because the NIC does not support. The other problem that I see at the software level is with banking apps or apps which use sticky cookies, as Gaurav mentioned. So banking apps will certainly break if the router just does dump switching of packets, right? Like if you go to netbanking.hdfc.com, it will just break in between that, say, hey, your session is being logged somewhere else. Uh, so unless you have some kind of intelligent splitting, right, maybe using host name based routing. Let's say this host name. Basically, you switch based on host headers, but then this only applies to HTTP. Again, it does not work on other types of connections. Other types of connections may use, let's say, proxy protocol. But again, uh, as you mentioned, right, the TP-Link hardwares are very common in India, but then having OpenWRT work on them is difficult. Even I can't run OpenWRT on my TP-Link router. So, uh, yeah. So one question to you: which router did you end up buying?
Is this question to me?
Yeah, it's
So I have a. Let me. So it's kind of a mini PC that I had picked up in my last trip to Shenzhen directly from the factory. So I've just put the link there. But I think it's available on AliExpress as well as I think on Amazon as well. So it's a 4-port kind of a mini PC router which runs anything that you want it to run. So I run pfSense on it, and yeah, so that's the one I'm using.
nice, cool. I'm just posting a link to the device that I saw. Probably it may solve some people's problem if they don't want like high bandwidth or can like circumvent net banking not working.
Right. I just have also shared the link for the OpenWRT hardware compatibility.
So Swapnil, Chinmay on YouTube is asking, unsure if a route, I'm not sure if it's a question though. It looks more like a suggestion. Unsure if it's a router, unsure if a router would work. Most routers have just a single WAN input, I think. And what you need is a LB switch.
Yeah, so the device which I have just put in the chat, that does. Even in the case of the OpenWRT one, so let's say the TP-Link examples which I was talking about, you could configure. There are certain models where you can actually configure devices to use instead of a LAN, configure it as a WAN. So you can have multiple WAN ports that can work. Yeah, I think Devang is also mentioning the same. Using OpenWRT, we can convert LAN port to WAN.
So it would need like chipset support, right? Won't it like it won't just suffice with software, right?
Yeah. So once you load the once you load the firmware, there are certain models where you know let's say when you load OpenWRT firmware, it will give you an option of whether you want to configure this as a as a WAN or a LAN. So you can select that this is one additional port that I want it to work as a WAN port. May not work for the base devices, the lot of base devices or the generic ones which are available here in India especially may not work for those. But I've seen there are certain models where it does that.
Interesting. Thanks.
I think I am good. Devang has a question. Any suggestion to monitor UDP-based traffics for ISP?
I didn't quite get the question, Devang. If you can clarify. Uh,
Yeah, hi, Swapneel. Am I audible?
yeah.
Yeah, hi. Yeah. So any tools just to monitor UDP based traffic, because sometimes I have observed that websites working fine, but when it comes to the streaming, okay, real time traffic, it causing a kind of latency or a jitter or delay in terms of response. So is there any specific tool for UDP or live real time traffic to monitor?
Um, I'm just trying to get an understanding on the question. So one thing, what you could definitely look at is use the RIPE Atlas probes if that makes sense. So if you have a probe in your network, so I'm not talking about probes in other networks, but you could use a probe which is in your network and run a measurement using that. And there are measurements for trace route, if I'm not mistaken, which can be UDP based as well. So you could use that as a base.
Yes, yeah.
And look into integrating that into something like Prometheus or using the Atlas exporter. That could be an option. Any other tool per se without using, nothing is coming to my mind. But maybe somebody else has any inputs. In the meantime, let me try to refresh if something can be that I can suggest.
Thanks, Swapneel. So I think UD trace route works on UDP, so makes sense. It should work. But make sure the port should be open on the other sides.
One thing about the Atlas probes, make sure you start running a Atlas probe which you can maintain. That way you'll start accumulating credits, and using those credits you can start monitoring your network and whatnot, and make sure your generation of credits is always higher than your spend. That way you won't like ever run out of credits. I think I learned this the hard way. I thought that as soon as I would have a Atlas probe, I'd be able to run all kinds of measurements, and turned out that I ran out of credits pretty soon. So yeah.
So I am a millionaire. I have millions and millions of credits because of all the probes that I run in a number of networks. But so if any of you, I mean, my first suggestion to people here in the room, as well as people who may watch this later, is to host a probe in the network, because that's a good thing to do for the community. But in case if you need a credit voucher, feel free to reach out. I can give you a credit voucher which you can use to run measurements, right? Because I understand a lot of people do not have compute to install a software probe especially in home networks. So I understand the limitation. Not everyone will have let's say a Raspberry Pi or an Intel NUC or or a server like I have in my bedroom right now. So having said that, feel free to reach out if you'd like to run measurements.
Any other questions? I guess not. So if everyone's comfortable, maybe we can start wrapping things up. I wanted to say thanks to like a couple of people, like Karan, certainly for publishing his blog post and getting this entire conversation started, and to Hasgeek as well for providing a platform where we could actually have this conversation, and Swapnil also for being volunteered by Zainab, just like me, for helping out.
Yeah, certainly. I mean, because of that one forum discussion, I learned about Telegraph and a couple of other things from you, Gaurav. And certainly thanks to Swapnil for his last Tribe Atlas probe session, because that helped me get started with hosting a probe, and in fact I'm hosting 2 probes right now. So yeah, thanks to some.
Maybe as a suggestion, what we could also do is we could even after the the webinar is the recording is turned off, we could hang around in case if somebody still wants to has any questions, or maybe could not join and could hang around for some time, if that works for both of you, if that sounds acceptable.
Yeah, sure. I can hang out for some time.
So Anubhav has a question. Can we somehow prevent ISP to stop our data to be read? Do you want to take on that, Swapneel?
Change your ISP. I think it's a very broad question to begin with. I mean, there are a number of things that one can do, especially depends on the endpoint devices and what options you have available. But I think one is encryption to begin with. So using a VPN, something that again this gets thrown out quite a bit with regards to use a VPN or use this VPN or that VPN. But then again, I think it's important to understand that the other side of VPN or the VPN endpoint that you're connecting, that is something that you should be able to trust. And if that's not the case, then you're just moving the needle from the ISP to the VPN provider. So one option is to run your own, roll out your own VPN for that matter. So you could explore OpenVPN or even WireGuard. It's a fantastic product, and it's kind of gone mainstream with regards to support in all operating systems, even OpenBSD. I think OpenBSD is going to have support for WireGuard in 6.8, I believe. Apart from that, I don't have any specific advice per se. It's more on what is your risk, assessment of what is the threat. So this is a security. I'm talking with a security hat that I've put on. So it depends ideally on what is you are trying to do. So there are certain things where there are certain devices. Say for example, let's say my TV. I cannot put a VPN on it. I could ideally I could put that, but then I need something on the edge of my network. So you need to then explore about a router or a device which you can configure VPN in it, so that your whole network would technically be protected rather than one single device. So I guess it depends on what you are trying to do, as well as the amount of effort that you want to put into it. But having said that, with DOH, in the pipeline, DNS over HTTPS. The DNS element is going to move away from the ISP, or so it was thought. So the IETF standardized DOH, which is RFC 8484, and with the assumption that there are going to be certain trusted providers who are going to be DOH providers, and there is Cloudflare, there is Comcast at this point of time, there is NextDNS, and I think these are the three ones which are there in the trusted recursive resolver program which Mozilla Firefox has. So what it technically means is the DNS communication between your device and the recursive resolver is not going to be in plain text. It's going to be encrypted if you're using DOH. So Mozilla Firefox already has this. But now, if you look at what is happening in the US, all ISPs are starting to roll DOH endpoints, which means that all consumers who are under the ISP are technically use the ISP's DOH resolver. Of course, I'm sure there would be an option which people can choose. So it's like moving the needle in a lot of ways. Having said that, it ideally depends on what you're trying to do. So DOH will only encrypt traffic between, the stub and the recursive resolver. Apart from that, any other traffic is not going to be encrypted. Yeah, so that's what I can add to it.
I have a small suggestion, like Swapneel mentioned, WireGuard is pretty popular. Now the thing is, let's say you host a VPN, but your queries are DNS queries are going to your ISP server. So that sort of doesn't give you entire privacy from your ISP. So maybe that is something that you need to look as well. And you can choose unbound, or there are a lot of self-hosted DNS resolvers or stub resolvers that you can use in your VPN server as well. And that solves the issue of DNS queries going to your ISP. Another thing is SNI. So a lot nowadays browsers are coming with the feature where you can put SNI protection on it, so that even if you're sending the queries to queries via VPN, the HTTP headers or the ISP is basically not able to inspect any of that. But I'm not sure about the deep packet inspection aspect, because a lot of ISPs are believed to run those as well. So complete privacy, I mean, that you cannot achieve even with a VPN, and that's what I believe, at least from a very security and foolproof kind of way. But in general, if you want to have all these basic things, I mean, yeah, 90% of that use case is covered.
I just wanted to give a quick shout out to Pi-hole. I've been using Pi-hole for quite some time and I'm satisfied.
Yeah, even I have Pi-hole in my stack, so Pi-hole is fantastic.
So I have a different. So in the case of Pi-hole, my primary grouch with Pi-hole is the fact that the default installation uses DNS mask, and it doesn't use unbound by default, because unbound is such a polished open source recursive resolver, and it's highly maintained as well as RFC compliant more specifically. So that is a lot of people install a Pi-hole, but they're using DNS mask behind the scene. So if you look at the Pi-hole documentation, there is somewhere down the line you have an option, or if you want to install unbound, here is what you do. And I have been pushing, sending out tweets to these the Pi-hole developers saying that why not make unbound as the default, because it gives you so much more. Unbound, by the way, has rolled DOH support just last week, so that gives you an additional advantage. For these very reasons, I stopped using Pi-hole in my network. So what I run is instead unbound recursive resolver with response policy zones. So response policy zones is basically DNS firewall, and it allows you to block uh, DNS traffic based on kind of policies or rules, just as you would have in a firewall, a real firewall, but more at the DNS layer. So feed in threat intelligence data into the DNS firewall, and now it's kind of extremely cost effective, at the same time very powerful layer of protection for any kind of network, not only home network but even enterprise networks per se. So if somebody is interested to check that out, feel free to look into dnsrpz.info. That's the website. And it's supported by all, even though it's not a standard yet, it's supported by Bind, um, Unbound, Power DNS. I think Cannot also does. I'm not sure about whether Cannot does it or not, but I mean, all open source DNS recursive resolvers supported. So you could explore that.
I have a quick question. The thing you mentioned about putting threat intelligence data. So is it similar to Pi-hole filter list, where you can feed in basically a text file which has a list of all the malware tracking domains, and Pi-hole just simply blocks out of that.
Yeah. Yeah, so you could use the existing, like let's say Stephen Black is a very popular the host file, right? It's a very popular and I think it's default in Pi-hole as well. So you could take that. In fact, I had a issue to convert the Stephen Black host format into a zone file, right? And one of the developers actually did that, so you have that as well. I think the website is Script Tiger or something like that. Maybe I'll put a link to that in the chat. So you could, so there is a bit of a work involved in case if you want to kind of shift from a Pi-hole setup to a DNS response policy zone. Although it's both are DNS based recursive resolvers, the only difference or the major difference is this is going to be based on zone files. This is a flat file. Pi-hole uses something like a flat file, right? So you use that data and you convert it into a zone file format, the RPZ format, and you have a full-blown response policy zone or a firewall. So you can even be selective in the sense that this is something that the Pi-hole did not have up till version 5, and I think before 5 it did not have this, is the fact that you could selectively allow or block domain names. So I could say, so in my lab right now, so when I'm doing some kind of testing with respect to say malware, I want to make sure that that device, if it is making an outbound request to any sort of DNS domain name, I don't want it to resolve. I want it to resolve with a NX domain response. So you could configure it that way. But I guess the Pi-hole version 5 and above also has an option to do that.
Yeah, after tinkering a little bit with my home network, it turns out that this is kind of a rabbit hole. You can go as deep as you want to.
The peak is when you have server equipment in your bedroom, and the only thing that remains is you need to get a rack. So that's the stage which I'm into right now.
The DNS response zone looks pretty interesting, but I just that reminded me of another thing, which is Cilium. Cilium is basically networking, basically a networking agent for Kubernetes, and it allows you to set up DNS-based policies for firewalls, and it does that using BPF. So yeah, that is this eBPF space is also picking up quite some interest of late. So yeah, that is it.
So a bit of a shameless plug. If anyone is interested for learning more about DNS response policy zones, I gave a talk, I think last year at HasGeek Pune about it. Plus, if you search on YouTube for DNS response policy zones as well as my name, I think there are going to be multiple talks which I've given, which will probably pop up. So you could explore that. And if you have any questions, you can reach out.
Cool. It seems like everyone's satisfied with this discussion. At least I was. So I think I'm gonna drop now. And yeah, thanks for this informative session. Even I learned quite a few things, so I'm gonna go look it up later. Cheers.